Praxis Digital Diary number 5. I was given 1 ethinyl 4,4-dimethylcyclohexane and asked to complete the reagents for the following 3 reactions. For the first one, the product is anti-Markovnikov alcohol placement. So I chose the BH3-THF sodium hydroxide and peroxide reagent. The BH3 adds to the anti-Markovnikov, and the sodium hydroxide and H2OH replaces the boron and replaces the boron with the alcohol group. The second one, we're given this product with the chlorine atom and the Markovnikov rule. So I chose hydrochloric acid with ether. That'll give me the chlorine atom on Markovnikov rule on the most substituted atom, carbon atom. The third one that I was given, the product is 2 alcohol groups, one on an alcohol group on the most substituted and on the less substituted. It is a cis hydroxylation, so I have OSO4 with pyridine and sodium hydrosulfite. I want to say sodium hydrosulfuric sulfur acid and water. Gives 2 alcohol groups. The second part of prepare the compound shown below from acetylene. Acetylene is a triple bond, carbon-carbon bond, and the product is a 4-carbon chain with an epoxide. So the plan is to elongate each side with 1 methyl. Second is to convert the triple bond to the pi bond. Third, the pi bond is also converted into trans, which we can see this methyl right here is opposite to the other terminal methyl on top. And then the fourth step is to add the epoxide. So for elongation on both sides, we use the sodium amine with liquid ammonia. It creates the acetylide ion, and then you can add the methyl group with the alkyl halide attached to it. That adds a 3rd carbon. We need a 4th carbon added on to the other end, so we do the reaction again with the same reagents and the same additional carbon methyl atom carbon group, adding a total of 4 carbon atoms with a triple bond. Now we have to convert the triple bond into a pi bond in a trans format. So I use lithium and liquid ammonia. That converts it into a pi bond in a trans configuration. And now we add the epoxide group, and that reagent is H2PD over methanol. And that gives me the prepared substance or molecule or compound, I guess. And now the second part is stereochemistry. It asks me which molecule is the same stereoisomer as the one in the Fischer projection. To go about this one, I had to figure out the configuration of the stereochemistry for each chiral carbon. So carbon 2 is R, carbon 3 is R. So it's a 2R, 3R stereoisomer. And the stereoisomer of it will be 2s and 3s. The question is asking me which molecule is the same stereoisomer, so it's asking me which molecule in the 4 options is 2R and 3R. And my answer for that was B. B is a mirrored image. As you can see, it goes 2R. The high priority carb atom is chlorine. Second is the 3rd carbon attached to it. 3rd is the methyl and 4th hydrogen. It's going clockwise, so it's R. For the 3rd carbon, the high priority is chlorine. 2nd priority is the carbon attached to the 3rd carbon. 3rd is methyl, 4th is hydrogen. The hydrogen is pointing towards us, so when I do the arrow rotation, it is an S, but you have to convert it to the opposite side for an R, so you get 2R and 3R. That's the mirrored image.